This is the problem on the metal forging, and it says at a fabrication plant, a hot metal forging has a mass of 75 kilograms and a specific heat capacity of 430 joules per kilogram in Celsius degree. And when you look in the table, that could be steel. Its specific heat capacity is pretty close to that. To harden it, the forging is immersed in 710 kilograms of oil that has a temperature of 32 degrees Celsius and a specific heat capacity of 2,700 joules per kilograms in Celsius degrees. The final temperature of the oil and forging at thermal equilibrium is 47 degrees Celsius, assuming that heat flows only between the forging and the oil. Determine the initial temperature of the forging. So the clip art that I found here is this one here, some kind of oil drum here. So we assume that that originally is at 32 degrees Celsius, which is in the neighborhood of 95 Fahrenheit. And then we put some metal in here, and that's kind of the only thing I could find here in the clip art on the software. And then this one here is really hot to begin with, so I should maybe shade a little bit reddish, it kind of starts to glow reddish, and we put it in there and it sizzles a whole lot here. Some of the oil, I guess, may evaporate upon contact, but they actually exclude that, so they exclude the latent heat of evaporation in this problem here, and just say, hey, the oil heats up uniformly to 47 degrees Celsius, and this one here then cools down to 47 degrees Celsius, and we're supposed to figure out what's the original temperature, respectively. We figure out first what is the temperature decrease of the metal here, and we do have given the temperature increase of the oil. We have given the mass of both the metal and the oil. We have given the specific heat capacity of both the metal and the oil, and when you look at that, it shows that the algebra is going to be the same as in the previous problem. So all I have to do is paste that algebra in here, and instead of wasting your time this time around, I already wrote it down as that for the metal the heat flow is this, for the oil the heat flow is that. Then the heat flows into the oil, so this one is positive. The heat flows out of the metal, so this one is negative, and therefore in order to equate the two here, I put an additional negative in here. So this is a negative of a negative, making that positive then. And then this one here is for the oil, this one here is for the metal, this one here is for the oil, this one here is for the metal. So you come up with some kind of temperature difference. This one here will come out to be a negative number, a relatively large negative number in Celsius degrees, and then the final temperature was 47 degrees Celsius. Always that 4. Never get rid of that. 47 degrees Celsius was the final one. So you add just this number here to it, and you come up with that the original temperature of the metal forging, so T0 of the metal forging, was a pretty large number in Celsius degrees, in the neighborhood of 900 or so. So this one here comes in therefore also up to kind of like a decrease of almost 900 degrees Celsius down to 47. That means the original temperature was somewhere around 900 to 1,000 degrees Celsius, and you'll figure that out. Again, everything is given here. This one is given in the problem as, what was that, 430 joules per kilograms Celsius degrees. The mass here is 75 kilograms. The delta T here for the, I'm sorry, hold on. This is for the oil here. So this, what I just said, 430 and 75 is down here, and then up here is for the oil 2,700 and 710 kilograms, and then the delta T for the oil is 15 Celsius degrees. Everything is given. You come up with the numbers.